All right, so if you remember in our last video, we talked about the remainder theorem, and the remainder theorem says that when a polynomial f of x is divided by x minus a, the remainder is equal to f of a, okay? If the remainder is 0, then x minus a is a factor of the polynomial. So this right here, what we have right here is the remainder theorem, okay? We actually talked a little bit more specifically about the factor theorem, and the factor theorem right here is a special case of the remainder theorem, okay? So the factor theorem says, basically, if f of a equals 0, then x minus a is a factor of f of x. Okay? All right, so let's take a look at example number 1. In example number 1, I'm going to try to see if I can factor x cubed plus 4x squared plus x minus 6 completely. So the first thing I'm going to do is I'm going to try to use conventional factoring methods and see if this is going to work for me. So the first question I always ask myself is there GCF? Well, there's nothing in common with my terms, so there's no GCF. The second question I ask myself is it a difference of perfect squares? It's not, because it's not a binomial. Third question is it a trinomial I can factor? No, it's not. So now I'm going to try to see if I can factor by grouping. So I'm going to group x cubed plus 4x squared together, and then I'm also going to group x minus 6 together. So when I group these two terms together right here, I'm going to factor out a GCF. Well, what's in common with x cubed and x squared? I've got x squared. So when I factor that out, I end up getting x plus 4, okay? And then here, there's nothing really in common, so I'm going to factor out a 1, and I get x minus 6. Well, in order for grouping to work, this term and this term have to be identical. They have to have a common factor, and they don't. So that means that grouping is not going to work. So we can cross off grouping as an option. Well, if grouping doesn't work, then we have to go to our factor theorem. So we're going to try our factor theorem. First thing I'm going to do using the factor theorem is I'm going to let f of x equal x cubed plus 4x squared plus x minus 6. Okay? And if you remember when we looked at it, if f of a is equal to 0, then x minus a is a factor. Well, here, this a value, we don't know anything about this a value right now, so I'm just going to randomly choose an a value and I'm going to plug it in. So I'm just randomly going to choose 5. Why? Because I just like the number 5. So when I plug 5 in, I will end up getting 5 cubed plus 4 times 5 squared plus 5 minus 6. So this ends up being 125 plus 5 squared is 20, multiply that by 4, you get 100, plus 5 minus 6. Well, when I add all of that together, I get 224, which means that I don't have a remainder of 0. My goal is to get 0. So that means 5 is not what a is. Okay? So let's try another value. Let's try -4. Why am I choosing -4? Because I just randomly want to. So let's do f of -4. So it's going to be -4 cubed plus 4 times -4 squared minus 4 minus 6. Well, this turns into -4 cubed is -64. And then, -4 squared is 16. 16 times 4 is positive 64. Minus 4 minus 6, so this ends up giving me -10. So that means that a cannot equal -4. Well, there are infinite values that a could be, so how is this theorem useful? If I just go through and just try a bunch of numbers, I might not ever get anywhere near to the number that I want. Let's just try one more, and then let's see if we can find any conclusions based on what we're trying, okay? So let's try f of 1. Let's see what happens when I do 1. So 1 cubed plus 4 times 1 squared plus 1 minus 6. So I end up getting 1 plus 4 plus 1 minus 6. So I end up getting 0. So that means that a can equal 1. So this looks promising. Now, that means that x minus 1 is a factor. So let's go ahead and see what we can do with this. So again, if we know that f of x sorry, let's write this out properly. If we know that f of x is equal to x cubed plus 4x squared plus x minus 6, we know that a factor is going to be x minus 1. But the question is, what goes inside of here? Well, that's where we bring back our synthetic or our long division. Now, you can do either one. I'm going to use synthetic division because synthetic division is faster. So since my a value is 1, I'm going to put a 1 right here. Here I use my coefficients in descending order, and I make sure that there's a coefficient for each term. So if it goes to the power of 3, 2, 1, 0, there's a coefficient for each term, so we don't have to worry about adding any zeros in. So my coefficients are 1, 4, 1, and negative 6. So let's go ahead and do our synthetic division. Don't forget, we always bring the 1 down. 1 times 1 is 1. Add these together, 4 plus 1 is 5. 5 times 1 is 5. Add these together, I get 6. 6 times 1 is 6. Negative 6 plus 6 is 0. We have a remainder of 0. We know for a fact that x minus 1 right here is a factor, and this remainder of 0 should be no surprise because our factor theorem told us that if we plug in an a value that would give us a factor, then we should get a remainder of 0. So what does this mean? Well, this right here is going to be my 0th term. This is going to be my first degree term, and this is going to be my second degree term. So that means that I end up getting x squared plus 5x plus 6. 1x squared plus 5x plus 6. Well, now that I've done that, this piece right here is super easy to factor. I don't have to worry about the factor theorem anymore. So let's see what ends up happening. So I end up getting f of x is equal to, my first factor is x minus 1, and now I'm going to factor x squared plus 5x plus 6. Well, I know that my factors have to have a product of 6 and a sum of 5, so that means it's going to be x plus 2 and x plus 3. Now, one thing I want you guys to notice is these values right here. Our a value here was 1, our a value here was negative 2, and our a value here was negative 3. So what do these numbers have to do with a certain number right here? Well, these are factors of my constant term right there. So that will help me to narrow down which numbers I can plug in as opposed to having infinite numbers to choose from. So I need you guys to write this down. This next piece of information I'm going to tell you is super important. To find possible a values, use factors of the constant term. That is critical, okay? That narrows it down quite a bit for us because, again, we start off with infinite possibilities. Here, we can narrow it down to much less possibilities, a finite number of possibilities, okay? So let's apply that information to this next example right here. Factor x cubed minus 5x squared minus 2x plus 24 completely. So right here, the first thing I'm going to do is I'm going to figure out all my possible a values. Well, my constant term is 24 right here. So this is my constant term. So I'm going to look at all the possible values of a that could work, all the possible factors of 24. Well, we know that 1 is a factor of 24. We also know that 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor, 8 is a factor, 12 is a factor, and 24 is a factor. So these are possible values that we could use for a. However, 1 could be a factor, but negative 1 could also be a factor. 2 could be a factor, or negative 2 could be a factor. So what I'm going to do is I'm going to say that all of these values are factors using their positive and their negative values right here. So, I mean, with the number 24, since we have so many factors right here, it still is going to be a little bit daunting. We've got 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2, we've got 16 factors. So we have to test maybe 16 numbers, possibly less, but definitely better than infinite values to check. So let's go ahead and start checking. Let's try f of 1. So f of 1 is going to be 1 cubed minus 5 times 1 squared minus 2 times 1 plus 24. So I end up getting 1 minus 5 minus 2 plus 24. So this ends up being, the value that I end up getting right here is 18. So since we get 18 right here, 1 is not a value for a. So a will not equal 1. Let's go ahead and try negative 1. So let's see what happens if we use negative 1 instead of 1. So f of negative 1 is going to be negative 1 cubed minus 5 times negative 1 squared minus 2 times negative 1 plus 24. So this ends up being negative 1 minus 5 plus 2 plus 24. So I end up getting f of negative 1 is equal to 20. And again, I want you to double check this stuff in your calculator to see if you totally agree with what I'm saying. So since 0 is not my f of negative 1 value, a cannot be equal to negative 1. So these values right here are out. They don't work. Okay, so let's go ahead and try f of negative 2. So if I were to do f of negative 2, it would be negative 2 cubed minus 5 times negative 2 squared minus 2 times negative 2 plus 24, and we would double check everything in our, when we're actually doing our work. So negative 2 cubed is negative 8. Negative 2 squared is 4 times negative 5 is negative 20. Negative 2 times negative 2 is positive 4, and then plus 24 right here. So we end up getting negative 28 plus positive 28. So then we end up getting f of negative 2 is 0. So that means that a can equal negative 2. Therefore, x plus 2 is a factor. Once we find 1, it makes things significantly easier for us to find the remaining factors, okay? So if x plus 2 is a factor, remember we have f of x is equal to x cubed minus 5x squared minus 2x plus 24. So now that we know that x plus 2 is a factor, we can say x plus 2 times something. But how do we figure out what this something is? Remember, again, we're going to use synthetic division. So for synthetic division, I know that my a value is negative 2, so I'm going to put negative 2 here. My coefficient for my cubic term, or my third degree term, is 1. My second degree term is negative 5. The first degree term is negative 2, and the 0 degree term is 24. So I bring down the 1. 1 times negative 2 is negative 2. Negative 5 and negative 2, and I add them together is negative 7. Multiply negative 7 by negative 2, you get 14. Negative 2 plus 14 is 12. 2 times negative 2 is negative 24, so I get a remainder of 0, which is exactly what I want. So now I know that what goes inside of here, since this right here is my remainder, right? That means that this is my 0 degree term, my 1 degree term, my second degree term. So this is x squared minus 7x plus 12. Okay, so now that I've done that, the rest of this should be easier for me because this is factorable. Okay, so that means I end up getting f of x is equal to x plus 2 times x minus 3 times x minus 4. Where did I get negative 3 and negative 4 from? They have a product of 12 and they have a sum of negative 7. So my answer to the question, which is to factor the expression, is going to be x plus 2 times x minus 3 times x minus 4. Take a look at this example right here. Factor 4x to the power of 4 plus 6x cubed minus 6x squared minus 4x completely. So when I look at this example right here, I see that I need to factor out a GCF. There's something in common with all of my terms. My coefficients have a 2 in common, and they also have an x in common. So I'm going to factor out 2x, and when I do that, I end up getting 2x cubed plus 3x squared minus 3x minus 2. Okay, so now that I've done that, I'm going to look and see if I can factor by grouping, and it does not appear that factoring by grouping is going to be a good option for what I have inside of here. So because of that, what I'm going to do is I'm just going to focus on what's inside of my brackets. I'm not so worried about my GCF at this point in time. So I'm going to let f of x equal 2x cubed. Again, I'm just doing what's inside of my brackets, plus 3x squared minus 3x minus 2. Okay, so once I've done that, I'm going to look for possible a values. Well, my possible a values are going to be factors of my constant term. So right here, my constant term is -2. So what are some possible a values? It could be plus or minus 1 or plus or minus 2. Well, this works out really nicely because we only have 4 options. So let's see what ends up happening. So I'm going to find f of 1 to start off with. So I'll do 2 times 1 cubed plus 3 times 1 squared minus 3 times 1 minus 2. So when I keep going with this, I get f of 1 is equal to 1 cubed is 1 times 2 is 2. 1 squared is 1 times 3 is 3. -3 times 1 is -3, and then I have a minus 2. Awesome. This ends up giving me 0. So therefore, a is equals 1 works. So x minus 1 is a factor. Okay, so if x minus 1 is a factor, let's go ahead, sorry about that, let's go ahead and use our synthetic division to figure out what the remaining values are. Well, since the remainder is 0 and we know that x minus 1 is a factor, let's go ahead and divide it out and see what our quotient is going to be. So again, I'm going to use synthetic division for me to be able to do this. So I'm only going to divide what we have in our brackets right here by our x minus 1 that we have here. So my coefficients are 2, 3, -3, and -2. And since my a value is 1, I'm going to use 1 in my synthetic division. Remember, bring the 2 down. So then I'm going to multiply 2 by 1. And I get 2. 3 plus 2 is 5. 5 times 1 is 5. -3 times 5 is 2. 2 times 1 is 2. We get a remainder of 0, which is exactly what we were looking for. So this works out nicely for us. So then we can say that this piece right here is equal to 2x. Don't forget this 2x on the outside, multiplied by x minus 1, because we know that's one of our factors right here, multiplied by, this is the 0th term, or 0 degree, 1st degree, 2nd degree. So I can say it's 2x squared plus 5x plus 2. So now the last thing I need to do, since this is quadratic, is just factor what's inside of here. I don't have to use the factor theorem. I can if I want, but I'm not going to. Just because it's quadratic, and it's nice and easy to factor. So let's go ahead and do that. Remember, we want our first term in each bracket to multiply together to give us 2x squared. So this works out nicely. Our only option is 2x and x. And then we want our last term right here to multiply together to give us 2. So we've got our options of 2 here and 1 here maybe. Let's see if it works. This gives me 2x. This gives me 2x. I want it to give me 5x. That doesn't work. So let's go ahead and switch them and see what we end up getting. So instead of putting the 2 here, I'll put the 1 here. I'll put the 2 here. This gives me 1x. This gives me 4x. Put those two together, you get exactly what you want, the 5x that you want. So, and we want them both to be positive. So it's going to be 2x plus 1 times x plus 2. And then I just copy down the 2x factor and the x minus 1. And this problem is now factored completely. Okay? All right. Example 3 is our last one that we are going to be looking at today, I believe. Yes, it's our last one. So it says to do some more factoring again. We're going to factor x to the power of 4 minus 6x cubed plus 2x squared minus 12x completely. Remember, we only use the factor theorem if we can't use conventional factoring. Well, it's preferable to use it only if we can't use conventional factoring. If you can use conventional factoring, you can still use the factor theorem, but it might be a little bit more work. So I'm going to see if I can factor this normally. The first question I always ask myself is there a GCF? And absolutely there is a GCF. My GCF is x. So I'm going to factor out an x, and once I factor out an x, I end up getting x cubed minus 6x squared plus 2x minus 12. Okay, then I look at what's inside of my brackets and I look to see, well, is this a difference of perfect squares? No, it's not, because it's not a binomial. Is it a trinomial I can factor? No, because it has 4 terms. So I'm going to see if I can factor this by grouping. So I'm going to group my first 2 terms in my brackets together and my second 2 terms in my brackets together and see what I end up getting. So I'm going to copy down this x right here, and then right here what ends up happening is I'm going to look and see if there's anything in common. Well, they have an x squared in common, so I'm going to factor out an x squared, and when I factor out that x squared, I have x minus 6 left over. Okay, and then over here with this one right here, 2x minus 12, they have a 2 in common, and when I factor that out, I end up getting another x minus 6. Well, since these are identical, it looks pretty promising. Don't forget to close your bracket that we had right here. It looks promising. I can factor out that x minus 6. So when I do that, I have an x minus 6 in common, and then what's left over is x squared plus 2. And then I just have this x right here left over, and I have factored completely without needing to use the factor theorem. So again, the factor theorem is kind of like a last resort type of thing that we'll use if we can't do conventional factoring. So like if you have a quadratic polynomial function, you probably don't want to use the factor theorem, but once we get into cubes and quartics and quintics and anything more than that, you'll start to want to use the factor theorem.